All right, guys, we're going to continue looking at this first section. Our focus today is just on symmetry. So we're just going to try and think about what's going on with that. We're going to take a look at graphs first, and then we're going to move on and deal with our equations or expressions as well. Um, Symmetry is something we're used to. We talked about parabolas, right? You have an axis of symmetry for those. I just did a quick little Google search, found some of these. But we have quite a few lines of symmetry here. Notice the things that we're most familiar with, right, is our x-axis, right? If we could fold it over. We are also familiar with the y-axis. And if you're reading through the text on that I just moved out of the way, notice we can deal with y equals x, right? So that's a diagonal line, or also working the other diagonal. So the square is actually our best option here. So negative x. Notice our arrows, we only have an x-axis and a y-axis. In the triangle, we only have a y-axis symmetry. The other ones are diagonals, and they don't appear to be y equals 1. And then the star, they're just all over the place. But notice we don't have an exact horizontal line of symmetry. So it gives us an idea of what's going on. Okay, so here's what we talked about is normally x-axis, y-axis, y equals x, and y equals negative x, right? So this is that diagonal through the origin, and this is the same thing, but the negative through the origin. So those are the four common places that we're really looking for. Another type is called point symmetry, and this is we talk about the center, right? So if we can turn it around, and normally we're going to talk about dealing with the origin. So could I turn the entire graph around and it would look exactly the same? That gives us point symmetry. In this case, we're going to think of the origin for that. Okay, so y-axis, remember the y-axis is this vertical one, right? So we're looking to see if we can fold our paper over, will we have the same thing? So we're looking for, as we look at testing any function, is if I can replace negative x with positive x, but y stays positive, or stays the same, I should say, either way. Okay, so in other words, if I can put in negative x and I get the positive x, then that's what we have some symmetry. Functions that have symmetry with respect to the y-axis are called even functions. So that's going to be kind of the last thing we deal with today. So what's this look like? Well, it should look pretty familiar. So y-axis symmetry, it's a parabola, right? Right. That's the one thing we're really looking for. If we look at it in a table, so notice my 3 and my negative 3 are both paired with 9. So this one happens to work out relatively nicely because it is just y equals x squared. But that's what we're looking for in the table, is to have that symmetry. We want to make sure it looks perfectly centered down the line. So we can find that on the table. Okay, and then this is the last part that we had in there as well. So what are you talking about? We're talking about something that's even. Okay, so we're going to call that an even function. If I can put in negative x and I get positive function with that, and we'll show you that here in the end. So the illustration, we could use a parabola like we have there, right? What's something else we know? The absolute value, that would work as well. And again, my highlighter, we're talking about the y-axis. All right, so what do we have next? We have the origin. Okay, so that means I can take, and for every negative x, negative y, we're going to get positive on the graph. Okay, so our test here is going to work like this. We're going to put in negative x, and we're going to get negative of the function. Okay, and this is like, what are you even talking about until we start to see it? So once we start plugging it in here, we're gonna make more sense of this. Right. And if we have that, they're called odd functions. Okay. So what would that look like? All right. So this is x cubed. Right. Remember, it looks like x squared on the right, but we can get the negatives on the left. And all that means is if we were to turn it around, right, if I turn this thing 180 degrees, it would look like the same thing. Okay. So taking a look at the table. So now instead of being exactly the same like we had before, I want a negative with a positive. I want a negative with a positive. I want a negative with a positive. Right. And these are going to be discussed, right? So we're going to plug in negative, and we're going to end up with negative of the function and that's called an odd function. So just laying out a lot of vocabulary. Notice the test itself is exactly the same, right? If I scroll up here, we're going to put negative x in, and it either becomes positive, right, the original, or it's going to become negative of the original, and then we'll know what's going on. All right, last one. All right, this is x-axis. Okay, so that means I'm going to leave x alone, but if I take negative y and positive y, they're on the same graph. So this would fail the vertical line test. And what's it look like? Right. It looks like kind of your square root function, right? Because that's exactly what would happen here is we take the square root, but we have to consider positive, negative. So we're going to get the bottom half of that as well. So notice what we have in the table is the x value. We have positive y for the x value. We also have a negative y, and that's why they're never a function because they fail the vertical line test. So I'm going to just drop one of these in here. So we have a picture of what it looks like. What's it look like on the table? Okay, so that means 9 has -3 and 3. Remember, if we were mapping, this would go to both because you wouldn't list both of them. So that's how we'd see that it fails the vertical line test, and it fails with that. All right, so the graphs of this kind of symmetry are not functions. Okay, we know it fails the vertical line test. All right, so let's take a look. Let's see what's going on here. Okay. All right, so determine whether it is symmetric with respect to the origin or not. So it's a yes or no type of question. And how do I tell that? Remember, we're always going to plug in. We're going to plug in what? We're going to plug in negative x. And if we wanted to say yes to this, that means the function itself has to turn out to be negative of the original. So let's start by plugging it in. So I went negative x cubed over 4 minus negative x squared. But what's negative times a negative times a negative? It's positive. So this is x cubed. Oh, I'm sorry, what did I say that for? Negative times a negative is positive times another negative is negative. So this would be negative. And then I have 4. And then this is going to be a negative times a negative, which we just said was positive. So it's minus x squared, right? Because this is going to turn right back to the way it was. All right, so let's see what happened. We started off with positive, positive, negative. Now I have a negative, positive, negative, which means this is the same as having a -1 in front of here, which means I can say it's -1 times x cubed over 4 minus x squared. Right, because this -1 would go in the top or the bottom, but not in both. Okay, so we would say yes. All right, and since we said yes, do you remember? Was that even or odd? Remember, if we say yes to being symmetric around the origin, it's an odd function. All right, so what we did here is we did f of negative x to get this whole thing. All right, let's try it again. This time we're trying to see, is it x-axis, y-axis, neither, or both, right? Because we could have both. So we're going to do negative x. So it's negative x to the 4th power plus 3 times negative x squared plus 8. When negative to the 4th power is positive, so it's x to the 4th to the 2nd power is positive, so plus 3x plus 8. So we find out that negative x is the same thing as the original. So guess what that is? If you plug in negative x and you end up with the original, that's an even function, right? And we know that it does have symmetry around the y-axis. So that's our y-axis, and we call it even because these two things get tied together. All right, so that was a little extra on our algebraic because I think those are the toughest ones. The other thing we can do is we can take a look at the graph, and so plug those into Desmos or graphing calculator and take a look at those graphs just to prove what we're saying is true, that it is symmetric around that y-axis. Remember, that's our vertical. Okay, so x to the 4th, what you're going to find out is this is actually kind of like a parabola, even though it's to the 4th power. It should be moved up at least 8 here. And then we're going to move on from there, probably be higher. So you might have to change your table just a little bit to see what it looks like. But if we were dealing with a parabola moved up 8, you would see that we are talking about something that is symmetric around that y-axis. All right, with our other one, we're going to have all sorts of branches and stuff going on. But as you spin it around, remember you're thinking 180 degrees, will it look exactly the same? So we'll take a look at that in class if you have questions. Okay, so if you can, put that in Desmos, screenshot it, and then we'll practice spinning that thing around. All right, so let's recap on our evens and odds. So if we take out the symmetry part of it, and we just say, hey, is this function even or odd? We're going to always test the same thing. We're going to replace x with negative x. So you get negative x, and we want to square it, minus 3. We kind of just did this one, right? So this would become x squared minus 3. So we end up with the exact same thing. And when that happens, if negative x goes in and we get the same thing as positive x, that's an even function. All right, let's try it again. This time we're going to plug in negative x. So negative x cubed and minus negative x squared. So negative x cubed is going to be negative x cubed. And here we're going to get minus x squared. So this one's a little bit harder to tell. If I factor out a negative 1, I get x squared or x cubed plus x squared, which isn't the original function either. So it's not even and it's not odd, so it must be a neither. All right, and in the last one, you could maybe guess. You think you want to guess, right? But we don't guess. We plug it in. That's what we do. All right, so we're going to plug in negative x, 5 negative x cubed plus negative x. All right, so negative x cubed, that's going to be negative x, and it's times the 5, so negative 5x cubed. Remember, only the negative x is being cubed. I'm going to go ahead and put these back together, and negative x, so minus x. Well, this doesn't look like the original, so let's do a GCF of negative 1 to see what happens. Oh, so if I pull the negative from each one, here's where we're at. Okay, so that means we put in negative x and we got negative the original function. So that makes this odd. Okay, so I think that's the toughest thing in this whole process, guys, is you have to determine about if the whole thing changed, right? We just want to be able to take out that negative 1 to prove this little negative 1 right here. So we're going to be very careful about finding a GCF. So if you're not sure, pull out that GCF, and that'll be your deciding factor between odd or if it's going to be neither. It's kind of nice if it turns out to be even, because then it should look like the thing we started with. So it's not a big deal. But if it's not even, we're kind of stuck between odd or neither. Pulling out that GCF really helps. That way you don't have to determine if with all the negative signs, if it's exactly the opposite, we'll be able to prove that right away. All right, so again, if you're feeling pretty good about these, then you can go ahead and get started with homework. Otherwise, we'll clear it up in class, we'll answer your questions, and then you can work independently from there.